Okay, so if you haven't gathered already, this week we're going to be talking about angle relationships. So we're going to specifically talk about angles of one intersection and two intersections. We'll try to keep this brief as we've had 3 other videos besides this one, so without further going. Okay, if we have 2 angles that share a side, that is called adjacent angles. Okay, so here you see a set of pink angles, and here you have a set of green adjacent angles. Okay, so we say that BAC is adjacent to CAD. Notice that this doesn't say anything about their measures, whether they're equal. It doesn't say anything about them being supplementary or complementary. All it says is that they share a side, so I want you to make note of that. Next, we have vertical angles. Now, it's kind of hard to pick these out if there's more than 2 lines intersecting, so I'll just keep it to 2 lines intersecting. These are the opposite angles in an intersection. So as we see here, 1 and 2 are the non-adjacent angles in this intersection. So those are vertical angles. Likewise, we have 3 and 4. Those 2 are non-adjacent, so these are vertical angles. So 1 and 2 are vertical angles, and 3 and 4 are vertical angles. Next, we have a linear pair. These are angles that are both adjacent and supplementary. Okay, so what does that look like? Well, it kind of forms a line here. Notice that if I look at angle 1 and angle 2, their non-shared side forms that light green line. Now, notice that you need both of these things to be true. You need them to be both adjacent and supplementary. Okay, so if they're adjacent but they don't add up to 180 degrees, then it doesn't work. And if they're supplementary, they also have to be sharing a side. The relationships of angles of one intersection, let's move up to relationships of 2 intersections. All right, so for this image here, we have to imagine us working with a sandwich. I know it seems pretty silly here, but a sandwich actually does a very good job imagining what these things might look like, okay? So here we have 2 of the 3 lines, and here's the 3rd line. Now this orange line is what we like to call a transversal. It might change, depending on the orientation of this image, but here's what I want you to imagine here. I'm going to keep these lines consistent here, the blue representing the pieces of bread and the orange representing the toothpick, okay? So keep in mind this image in the background. So you can all see the sandwiches in each of these portions, right? So let's first talk about the exterior angles. Okay, so these are the angles that are outside the pieces of bread. Okay, so we imagine these 2. Notice that these yellow angles are going to be identified. They are outside the sandwich. That's what it means to be on the exterior. Next, we have the interior angles. These are the ones inside the sandwich. Okay, so these are the angles here. There's 4 of them. If you count 1, 2, 3, 4 angles inside. Same thing with the exterior. There's 4 angles on the outside. All right, so we talked about inside and outside the sandwich, but let's talk about the toothpick now. So the next thing you can be on alternate sides of the toothpick. So if I'm looking here, I'm seeing this toothpick, I'm imagining that angles can exist on both sides. So we see that these 2 yellow sets of angles are on alternate sides, and same with this green set. The green sets are on opposite sides. The last case is you could have angles on the same side, and these are going to be the green ones here or the yellow ones here. Now, these are not specifically, if I ask for all the exterior angles, let's say, those would be the cases, top left corner here of yellow ones here. But these aren't the ones we really care about. Really what we care about are mixing and matching these so that we're really only looking at pairs of angles. Alternate interior angle. So if you get confused here, just think back to the sandwich and break down the pieces. So alternate means you've got opposite sides of the toothpick, okay? On the interior means that they're inside the sandwich, okay? So we actually have 2 pairs. Here's one pair. Notice, alternate sides of the toothpick inside the sandwich. The other pair, in green, alternate sides of the toothpick inside the sandwich. That's the first set that we care about, the alternate interior angles. Next, we have alternate exterior angles. Again, opposite sides of the toothpick, outside the sandwich this time, okay? So we've got the yellow pieces here. They are on the outside of the sandwich, on alternate sides of the toothpick. We also have the green ones. So we have two pairs. The same side interior angles are next, and we imagine, again, same side of the toothpick this time, but inside, okay? So we've got one set in green and another set in yellow. Hopefully that makes sense. It kind of makes sense before we get to the weird cousin is the same side exterior angles. Again, following the same pattern here, we are on the same side of the toothpick, but now we are on the outside of the sandwich, okay? So same side, we have yellow, and now green. Now the weird one. We are moving on to corresponding angles, okay? So the last four seem to follow that same pattern of same side or alternate and interior versus exterior. To understand this completely, you have to understand what corresponding means. Corresponding means matching. So what angles essentially are matching? Well, to understand this, I like to visualize this as two intersections with rectangles around them, okay? So look inside one of the rectangles. You see that it's divvied up into 4 sections. Both cases here have 4 sections. So if I talk about the top left corner, the top left section, that angle formed there in both boxes are corresponding. So in this case, we have these two angles right here are corresponding angles because they are in the top left corner in both cases. Likewise, these two angles are going to be corresponding angles because they are in the top right corner. Now notice, I didn't necessarily say that they were congruent. They aren't necessarily, and certainly not in this diagram. Next one, these two are going to be corresponding angles as well because they are both in the bottom right corner. Finally, these last set here in the bottom left are also corresponding. This one's a lot more clear as to the fact that they are not necessarily congruent. They are just in the same spot. Recap here. Here are all the big ones that you have to memorize, okay? So I don't know if in your notes you want to use different colors or if you want to number these, but these are very important in what we learn next when it comes to these parallel lines, okay? You need to be able to list these off automatically, okay? Remember that the orange line in this case is the transversal. You could also, one quick note here, this whole diagram could be turned sideways, okay? And in which case the sandwich is sideways and you have to kind of reorient yourself here. One other thing that I just realized is that all of these have 2 pairs in each of them, except for the corresponding angles. They have 4 pairs of angles that are corresponding. Okay, that's where I got my sandwich. Thanks for watching.